Now let's discuss the concept of phase velocity, which is purely hypothetical in nature, that's associated with matter waves. And if we start with considering wave motion, now what is wave motion? Now, wave motion is basically a form of disturbance which travels from one point to another point to another point due to the repeated periodic motion of the particles of the medium. And these particles are oscillating at their mean positions. And the motion being handed over from one particle to the next. And the individual oscillators which make up the medium, they only execute simple harmonic motions about their mean positions and do not travel. They don't travel themselves through the medium with the wave. Now, every particle begins its vibration a little later than its predecessor. That should be clear from the motion of these particles. And there is a progressive change that goes on, that goes on from one particle to another particle. Now, what can we say about this motion is that it is the phase relationship of these particles that we observe as a wave that's traveling from one particle to another particle. And the velocity with which this plane of equal phase travels, as it travels through the medium, we call this velocity as the phase velocity or the wave velocity. Now, if we go to the de Broglie wave, which is basically a matter wave, and we calculate this phase velocity, and if we calculate this phase velocity, it comes out to be, if we start from Planck's equation, E equals h nu, then I can have E equal to mc square, and here I'll have, I'm going to have here from this equation, I can write nu is E by h. And from here, if I use E equal to mc square, I'm going to get the wavelength will be h by p. Now, this will be the frequency of the wave, and this will be the wavelength of the wave. Now, to write a general equation for phase velocity, this v is nu lambda. So this Vp will be nu is E by h times h by p. So this Vp comes out to be, this is mc square by p. So this is mc square by mv. This m and m will cancel, so this Vp comes out to be c square by v. Now, what does it mean? It means, but we can understand here this phase velocity is exceeding the velocity of light. That we are connecting to de Broglie wave, to the matter wave, and we can say, if we take the relativistic situation of the same problem, here we can understand that this Vp, the phase velocity, is basically c square by v. Now, if we go to the relativistic consideration of the same problem, if we go there and use the relativistic energy, uh, which is uh, which is p square c square plus m naught c square whole square times raised power 1 by 2. This is the formulation, right? So I can think of using the expression for Vp as E by P that we did previously. So here, this is my, if I write in open form, this is m naught square c to the power of 4 plus p square c square whole raised power 1 by 2 divide by p. And if I would like to get this p inside, so inside I will have p square. So Vp in this case will be, yeah, it will be m naught square c to the power of 4 by p square plus c square raised power 1 by 2. And I can have, I can get c square out, and that will come out by killing the root. So I will have c, and inside I will have m naught square c square by p square. Now this p can be used from de Broglie equation as p is h by lambda is h by p. So p will be h by lambda. So this is h square, lambda square will come here, plus 1 raised power 1 by 2. Now we can see here, in the similar way, we can see here that the phase velocity is greater than c, because this whole thing that we have here, it's made of constants, and all of these constants we have they are the positive quantities, and uh, and and what will be Vp in this case? It will always be always greater than that of speed of light, taking into consideration the relativistic energy associated with the particle, and calculating its phase velocity. Now, as the material particle can never have the velocity equal to that of velocity of light. So, so it doesn't seem to be suitable to talk about a single wave that's associated with the particle. And further, if I would like to go in more depth here, even in free space, if we talk about the free space or vacuum, if I take the consideration of free space and vacuum, the velocity of this de Broglie wave depends on wavelength. So if it depends on wavelength, what does that mean? It means that the de Broglie waves of different wavelengths have different phase velocities. Thus, vacuum is a dispersive medium. It's a dispersive medium so far as the de Broglie waves are concerned. But it is not acting as a dispersive medium for electromagnetic waves, because the electromagnetic waves, in this case, the waves of all the wavelengths travel with the same velocity. So this marks the difference between the velocity that we are talking about, the de Broglie equation, where we have a particle and a wave associated with it. What we find here that the velocity of de Broglie wave is dependent on the wavelength. So even vacuum will be a dispersive medium for matter waves, but for electromagnetic waves, even though white light is made of many wavelengths, the light as a whole travels with the same speed, what's known as speed of light. So this could be a differentiating point between the phase velocity that's linked with the matter waves, and talking about the general electromagnetic waves.